In this video, I'll be discussing about conditional types and mapped types. So again, these two are additional or advanced concepts in TypeScript where you can derive other types from the existing types by using a condition, or you can map types, or you can generate new type of types by adding some additional information from the existing types, right? So both of these, again, on the same note, generics are something which store the types in a variable, and in TypeScript allows you to write or generate types from the existing type. So they fall under the same category, right? So first, conditional types. Conditional types are those types where you can derive a new type based on a condition, like we generally do, right? So in that fashion, how we can write a conditional type and what is the basic syntax of it, let's see once. Okay, so first, the basic syntax, right? Type, derived type. So I'm just explaining you how it looks like, right? It takes t, or yeah, now it checks t extends some other type, right? If t extends some other type, then the derived type is going to be one type or other type. So this is the syntax of a conditional types. Okay, let's see the use case of it, but first let's understand, right? So let me comment out this. So a simple example, type person data is equal to, right? Person data is equal to, or let me first define two types, interface person. Here I'll have name string. For time being, I'll just take two numbers. Here this mobile is string. So person with mobile string, some random interface. Okay, now I'll have person with mobile code, something like this, and here person, normal person, where person is mobile is in number, right? Now I want my mobile data type, basically, right? So if my mobile data type should be equal to string or number based on what type my data is coming. So it can be person with mobile code or person, normal person, right? In this case, it is depending on some condition. Like if mobile is string, then my mobile data should be of type string, right? In this case, what I can do is I can use the concept of generic, and also I can use the conditions like t extends person. If t extends person, it means my mobile is going to be number. Then I'll say the type of mobile data is going to be number, otherwise it is going to be of type string. So now when I get constant derived mobile or filtered mobile, right, is equal to mobile data. So I'll have two objects. Person1 is equal to name Iron Man, and mobile is of type some random 1 2 3 4 5 6, right? Another person, I have person2. Here the mobile number is number, so we can call him as Spider-Man, right? Now constant filtered mobile. So this type is basically it's going to be type or mobile data with type of person1, right? Now what is type of person1? Here the mobile is string. Hence, by using a generic and a condition type, I got to know that because this type is going to be of type person with mobile code, and this type is person. So now my filtered mobile is of type string, and when I put the type of person2, then my filtered mobile is of type number. So it means I have derived my filtered mobile data type from the existing object of person2, which is of type person. And how did I was able to achieve that? Using the conditional operator. Okay, so let me show you another example in the same manner in the conditionals, right? So let's assume there is a function. Okay, basically get headers function. Okay, function get headers. So basically in headers, when you see the request headers and all of this, there it can be an array and it can be a string as well, right? So some headers comes in the form of array like this, and some errors directly come in the form of string, right? So you have to check every time that if it is an error, get me the first value. If it is not an error, directly return. If it is not an array, then directly return the value, right? So here header value or directly value, if it is of type string, then it will be of type string, right? Again, get header or get header value, the second override, if value is of type string, then I will be getting string array of strings, right? And now the actual get header value can be, so this is my final override, string of array. So it can take both of these and it can return both of this, right? So here I have to define both of this or something of this sort, right? Because sometimes the value can be sometimes the value can be array, sometimes the value can be string of array, right? In these cases, this is going to be really troublesome, right? So simply what I can do is I can define a new condition, get header value return type. This is going to take t, and here t extends string, then it is going to be string, otherwise string of arrays. Okay, so if my type is directly string, then the return type is going to be string, otherwise the return type is going to be string of arrays, right? Now I can simply say if t extends, or let's say in the same get mobile number, let's go with the mobile number concept only, function get mobile number, right? Here the mobile number, basically if the object is person1, if the object is person1 or person with mobile code, then the return type is going to be string, right? Function get mobile number, if it is of person2, then the data type is person and the return type is going to be number, right? Sometimes this list can increase, right? And you cannot keep on writing all of these overrides again and again, right? Person string or string of array, but here you are getting a union of types, but indeed you want a definite type, right? String or number, right? in these cases, oh no, sorry, person or person with mobile code. So person can be person or person with mobile code, person dot mobile, right? So now it is supporting both string or number. But what if the condition is going to be large? Now it is just with the two cases. Are you going to define all of these overrides? Are you going to define all of these overrides? No, right? So you can simply do a generic type get mobile data of type T is equal to, if T extends number, or if T extends, oh, I already defined the type mobile data, right? So now I can convert this function to generic function get mobile number and bracket, angular bracket, T extends string, or no, T extends person or person with mobile code. Here my person object can be T, because it can be either person or person with mobile code, and the return type is going to be mobile data of T. So this is my function now. This is my function. Now I have to return something, that is if simply return person dot mobile, as I have to typecast it explicitly, mobile data of type T. So now when I go constant mobile1 is equal to get mobile number of person1 and constant mobile2 is equal to get mobile number of person2. So here it is string and here it is number. So we, even if you look at here, the function is saying the return type has automatically changed to string. Look at here. So it inferred the type of what is person1, and automatically the type definition has been changed accordingly. Instead of defining multiple overrides, which we have done previously, person with mobile code and person and return type going to be string. So this is going to be very cumbersome, and conditional types are going to be really helpful in such cases. And also there is another type which you can define called as flattened type, right? So let's see that flattened type once. Like I was talking about flattened type, right? So basically sometimes the array can be in the form of array where the first element is your value, or it can be direct value, right? It is possible totally. So perfect example is HTTP headers, right? In that cases you can define a flattened type which is going to take any argument. So here what we will do is we want our final thing. So basically we know that either the value is array of 0 or the value is direct value, right? So in such cases, how do you define a type which identifies what is the element inside that array and what is the element outside? So if it is a single element, right? In such cases, what you can do is, if T extends any of this, right? If T extends any of this, any of the array, then the value or the type of the value is going to be T of number, that is the first element, or otherwise it is going to be of type T. Now here, when I define such a condition for the flattened type, now my constant or my type for string elements is equal to string elements or request elements which are of type string. Then I can simply say flattened type of string of arrays. right? String of arrays. Now this is going to be a string, and if type string element is equal to flattened type of string. Now this is going to be of type string. So in both the cases it is string. So basically you don't know, now you are pretty much sure that you are passing string of arrays only, then it came to be this way. But what if you are doing like this, get mobile number of this sort, right? You don't know what it can be. Type of mobile one, right? So here, so now this goes to be a type string, right? This goes to be of type number. So your value is dependent on some other type and you're deriving it. So basically I have attached mobile 2 directly over here, but it can be anything. It can come from any server and anything, and based on that your flattened type is going to derive the element. So you're not looking at what the mobile is or what you're intercepting it and checking for the first number, but automatically this type is going to tell you what the type of data it is coming to be, right? So it says that the first element, since the type of this is number, it infers it and it gives you the return value of it, right? This is all conditional types. It's going to be really helpful. Like if you see here, if there is a function which is going to return array of strings and you are not really sure about the type, but you want the first element of that, maybe it is array of strings, maybe array of persons or anything, right? In such cases, so if I directly give person over here, this is going to become of type person, right? So if this person is an array, then it will automatically find the first element of it and takes the type of it, right? So this is all conditional typing. It is going to be really helpful to you in deriving the types from existing types based on a condition where it is checking if it is extending any other type, and if it extends, then it goes with the true branch, that is immediate after the question mark, and if it is false, then it goes on the left hand side of it, right? Next we'll move on to mapped types. So this is a very powerful concept, I can say, which can derive, modify or optionalize all of these existing types, right? So let's deep dive into the mapped types. Mapped types generally work on the index signatures, right? So for example, let me take a quick short example. Type data is equal to, right, key as string, and it can be of type person or person with mobile code, right? So this data, what it is, it can be on the left side, it can be any string, but on the right side it can be either person or person with mobile code, right? So if you define a data of this type is equal to, and here if I do this type data, then I can be like this, Vasudev, and my name is going to be Vasudev, and mobile is going to be 12356. So similarly, my backend data, whatever it is coming from, I can represent the whole backend data with this type structure. Now I know that the key is going to be a string. The key is going to be a string, and the data on the right hand side, it is going to be of type this or that. So similarly, Iron Man is equal to name Iron Man, and then mobile 12356, right? So these are index signatures which really help you to define a generic string or generic key where you mention that it can be any value of type string, but usually what we do, we mention like this. So instead of doing this, old data, ideally to represent this data, what you have to do is Vasudev person or person with mobile code. So in the same way, you have to define this for all the values. But the problem here is how much if the data comes any different one. So now see, old data and new data are same. But here the problem is it is a static one. You cannot keep on adding all of these structures again and again. But you have written a generic type where now you are ensure that it is okay if the string is coming anything as string, and the right hand side is a percent. So this is called as indexed signatures, right? Now mapped keys work on a similar thing. Mapped keys work on a similar thing, right? So let me check out. Let me create a new type functionalities. Right, type functionalities. Here type functionalities, here let's say our website has the functionality to update profile. Okay, this is a function. It is going to return void and it is going to check, it is going to take data of anything of that sort, and dark mode, and this is going to return nothing. Enable dark mode, light mode, of this sort, right? Now by using both key of operator and a new property in operator, a loop operator, I can derive a new type, that is type options is equal to property in key of functionalities is Boolean. Now what is options? So see, I have written a code. What it does is it has given me a new type with update profile, dark mode and light mode, and on the right hand side the value is Boolean. But what it is basically the keys of the functionalities type. The keys of the functionalities type, right? So now let's say we are getting percent data. We can pull it up from somewhere. If we have percent type, I don't think we are having it. Yeah, we have. I'll copy paste this. Type, similarly type TV is equal to, and let me remove this data, it is no longer needed now. And yeah, and this is of type monitor, right? Now I want to create a filters array. I want to create a filters array, filters type, right, based on each of this. So when laptop is there, the filters can be of this, and when TV is there, the filters can be of type this, and monitor is there, the filters will be applied on screen size, brand and mobile. So first thing what I can do is type filters TV, right? The type of filters inside the TV, it is going to be property in key of TV. The filter can be Boolean for true or false, it is available or not, right? Now if I see this, I got a new type, filters TV. I mean filters on TV, it makes more sense. Filters on TV, the filters on TV can be this, and similarly the type filters on laptop, whenever the filters data is going to be something of this sort, right? So over here, and now the filters of laptop is going to be screen size, brand name. Oh, I have mentioned TV over here, laptop, right? So the filters on laptop is now this. By looking at this, we are repeating some kind of code, right, to generate this, the same line. So immediately when you're repeating, go for a generic one. Type get filters type. This is going to be a generic, right? And what it's gonna return us? Property in key of t boolean. Now the type filters is equal to get filters type. So whatever the user is searching, if he is searching for laptop, then we are going to get the filters of laptop. If he is searching for TV, then we are going to get the filters of TV. So this is the power of both. Now you never defined any filters for TV, because you cannot do that for every TV, laptop and all. You're automatically generating those types and making your language strictly typed, and also you're using the power of generics over here to get that things done for you, right? So see, filters is the perfect example. When user wants to look at laptops, you can use this generic and you can get the type of filters available based on the data, and this based on this data you're actually getting all the filters using the mapped key properties, mapped key functionality. So this is one of the very good use case of the mapped keys, right? We have more functionalities inside mapped keys, that is, which deals with access modifiers, right? So basically type person is equal to, or I can copy, I think there is almost lot of persons, right? So, or yeah, type person's name is string and age is number and mobile is string and email is string. So now what I am doing is, I have made both mobile, email and age as an optional. Or no, I made both email and age as an optional, but for some so this is my generic, this is my normal type, right? So this data is going to be used on website and used on dashboards for local usage purposes, whatever application I am building, right? So for that purpose, what I have done is I have made few of the modifiers as read only, and it means they cannot modify it or they cannot change it in future. But you are now developing another application which is an application to change the person details, like a dashboard kind of thing, where you see all the persons and you edit their details, right? When we call to a bank and say that my my data is wrong, so this is what they are going to do. But you cannot see the same option on the website, right? In such cases, mapped keys again comes for your rescue. Now for your dashboard application, you either have to remove this manually, but right now you're seeing only 4 elements. Maybe that type is having around hundreds of data properties. In such cases, it becomes really difficult, right? So simply what you can do is type person or type editable person is equal to minus read only property in key of person is person of property. See, now what I have done, editable person. First, I have generated a new type, and from this I have removed the read-only property. So this minus read-only, it means that it removes that access modifier. It removes that access modifier from this person object. See, this person object has read-only, but editable person doesn't have read-only. So what I have done is, using the same concept of mapped keys, what I have done is property in key of person, and from the person, using the indexed signature mapping, I am getting the right hand property. So key of gives you the left hand side, key of gives you the left hand side, and property loops in. So we are looping in each of the data, and I'm looping all the name, age, mobile, and creating a new thing over here. And person of indexed property, this gives me the type that is on the right hand side. So I am able to get the same data type which was defined earlier. So this is used to modify your access modifier. Maybe right now I have made it private, public, and stuff like that. But now I can simply say I can remove all the private properties of this sort, right? So read only, this will really help you, right? Now the next thing is removing optional parameters. So if you just see, let me remove this. Now I have made few of the things optional on the website. So maybe when user is editing his own form, these fields are optional, but when user is filling a form or when user raises a complaint and we might need few of the details like this, then in such cases we can derive a new one, that is strict person. It means this should contain all the data, and here property in key of person is equal to, again, person of property, but option minus. So now when I did this minus of option or minus of question mark, what it does is it makes my all of the properties a strict. So see, now this strict person has no of the optional fields. In the same way, if I want to make it optional, now I can make all the details optional as well. So minus or plus, right? Both of these are going to be of my help. So right, so optional, I can remove something as an optional, or I can bring something as an optional. Both of these are possible with the help of mapped keys. Next, we will be looking into key remapping, or we can use the existing type to generate new types by renaming them. Okay, so let me do that. So basically this is person, right? Now I want type getters. So basically this is going to have get name is a function, and it is going to take something and return something, right? Similarly, basically it's going to take name, or it is going to take nothing and it's going to return the type of name, something of this sort, right? Now what I can do, or how we can use the typed keys or mapped keys to get me generated. So this is called as remapping, or renaming as key, okay, or key renaming, right? So I can do this type %getters is equal to property in key of person as get property. I have to make it capitalize, right? So get property. First we'll see what does this gonna do. So this is going to return me person of property. So now property, right? Now if I see the person getter, it is given me get name, get age, get mobile, get email. So what I have done is I have renamed my existing key to something else, and I have attached a totally no different type to this, right? So this is one more feature which you can do, that is key renaming, string renaming, right? Now to capitalize this, what we can do is capitalize, and it's going to take string and property, right? So one type arguments, that is string, and it is going to take property, right? So let me see what's wrong over here. The syntax, it is going to take only one argument, that is what it is saying. So capitalize s extends string, so basically converts first character of string literal type to uppercase. Now if I see the person getter, it has get name, get age, get mobile, get email, and I can remove the optional flag if it is present by minus. Now I got a good person getter. But again, if you want to define getters or setters, right, type person setter. Now here I can use property. Get used to this syntax, is very important. Key of person as set string literal capitalize, it is of type string, and property. So, and removing the optional flag, this is going to take arg of property type, person of property, and it is going to return void. So something is wrong. It is going to return void. Now the person setter object will have set name, set age, set mobile, and it is taking the perfect thing, string, number, string, and string based on this type, and also we removed the optional flag. Now we can use the power of generics to get the types of getter and setter by defining a generic type. So type getters of type T is equal to property in key of T, this is a generic, right, as get capitalize string and property. Now removing the optional flags and getting the function and T of property, right? Now to get the person getter, what I can simply do is getters of person. That's it. Now getters of person will have all the person getters, and type laptop getters is equal to getters of laptop, right? Gets name, get space, memory type. Similarly, I can write the same for setters as well. Setters of, so syntax, setters of generic type and property in key of t as set capitalize string and property string, somewhere it is gone. Yeah, angular bracket, yes, and then remove the optional flags and give me arg of type t of property, and return type is going to be void. Now this person setter can be easily derived by using the generic type which we have written, person setter and type laptop setter is equal to setters of laptop. So laptop setter, person setter, you can reuse this for any of the required things, right? So this is one of the powerful feature in mapped keys, that is key renaming is also possible based on using all of these concepts, right? The last feature which we can discuss about mapped keys is that excluding few keys. Right? So let's say you want only 3 elements, or you don't want any of the elements from over here, right, in a person object. So what you can do is type new person. It is really tough to name all of these types. And property in key of t or person, key of person, right? You have to exclude one key as exclude, right? Exclude property, comma, what property are you going to exclude? Email, right? And then this is going to be of type property or person of property. Awesome. Now the new person is going to contain only those details which have been excluded, that is email, right? So exclude basically takes exclude from t those types that are assignable to you, right? So t extends you, or you can simply say any property name over here, and that property will be excluded from the existing one. So these are the high level applications, or overall the generics and advanced types in TypeScript. And I would strictly say, or strongly say, that unless you don't know, or you are not writing your code in this, you are not an advanced TypeScript programmer. You need to have a very keen looking at your code, or how you're writing, or how you're developing your application. And that's how the actual types are going to be maintained, right? So this is very, very important, advanced type and generic type, and how you can combine both of these to actually generate the types automatically and write more reusable code for your application, right? Cool.